So we have arrived at question number 6 on the past paper practice of the topic work, energy and power. The question that you see on the screen is from your AS Physics past papers. You can pause the screen here for a while, attempt this part of the question. Then I'll show you the second part. Here you have the second part. Pause the screen here as well and attempt the question, the second part of the question as well. I'll show you the working and sometime then you can tally your answers and score yourself, and let me know whatever is your total score. Let me know in the comment box, and if you have any queries or questions while going through the explanation, do ask them in the comment box so that we can have a discussion there and I can clarify your doubts. So let us come to the first part of the question and let us solve it. State what is meant by work done. What is work done? Work done is force multiplied by S. What is S? S is displacement. Displacement in what direction? In the direction of the force. Very, very important. Let us study our answer with the mark scheme. So this is exactly what we have done. Force times displacement in the direction of the force. Make a note of it as well in your notebooks to understand how work done is defined. So these are some of the notes that you can make somewhere in your notebooks, because these are a kind of question which keeps coming every year. And you should know precisely what Cambridge expects you to write in the definition of work done. A trolley, now here let us understand the question. A trolley of mass 400 grams is moving at a constant velocity of 2.5 meters per second to the right as shown in this figure. Show that the kinetic energy of the trolley is 1.3 kgs. Do I really need to solve this question for you? No, I know you are intelligent enough after going through my theory videos and through a lot of the past paper practice. Easy, very easy questions. Kinetic energy is half mv square. Substitute the values. Only thing that you need to take care of is that all the values should be inputted in the SI units. So this gram is not a SI unit, you'll have to change into kilogram. 0.4 times velocity 2.5 squares. Work it out and see. Did you all get this answer? If yes, you are correct, you can give yourself 2 marks, 1.25 or 1.3 if you round it up. 1.25. Do not forget the unit. Unit is important, otherwise you lose marks. Now the next question. The trolley in B moves to the point P as shown in this figure. It's the same question, same data, but some additional information has come in here. At point P, the speed of the trolley is 2.5 meters per second at point P. A variable force F acts to the left of the trolley as it moves between point P and Q. So there is a force acting as it is moving between point P and Q. The variation of F with the displacement from P is shown here. So backward force is acting and still the trolley is moving from P to Q. What kind of a graph it looks like? It looks like a spring graph. Looks like, you can imagine that there is a spring. There is a spring here which is kind of pushing it backwards with this force F all the time. You can imagine all these things happening, though it is not given in the picture. There can be some other scenarios. It is pushing it backwards, right? Similar kind of a situation. So you can apply similar scenarios of your springs, understanding the springs, understanding of the force versus extension. The same principles you can apply here to work out the questions which are given later on as you proceed through this question. The trolley comes to rest at point Q. Calculate the distance PQ. How do you calculate the distance PQ? How much of a work would you do when you're moving from PQ? How do you find the work done from a force extension graph? Half time F times X. It is the area under the graph. Area under the graph gives you the work done for a force extension graph, or the force compression. Force extension means the same thing. Let us call this base be X, and this is the distance X moved. So let us understand what is the force. Force looks like to be 1, 2, 3, 4, 14 newtons. So let us substitute. So how much should be this work done be equal to? This work done should be equal to the initial kinetic energy that you started with, using the law of conservation of energy. Energy does not get created or destroyed, it stays conserved. This should be equal to 1.25. So let us substitute the values here. 1 by 2 times 14 times X is equal to 1.25, 7. So X should be 1.25 divided by 7. Work it out and see if you're getting the correct answer. Here it is. You should be getting 0.18. This is the distance. Unit is already given, so you need not worry about it. Alright, so let us look here. So on this figure 3.5 sketch the variation of X of the velocity V for the trolley moving between P and Q. So you have to sketch the graph, how it would look like, of velocity versus displacement. What was the initial velocity at point P? When the displacement was 0 at point P, the velocity was 2.5, and finally at the point Q, the velocity was 0. Join them with a curve and that should be your answer. So here is your mark scheme. You can refer to the mark scheme, read the mark scheme as well, and then understand and find out if you have any alternative way of doing these questions as well. Do share in the comment box so that I can also have a look and other students can also have a look and understand your point of view as well. Thank you so much then.